Hi viewers, welcome to the channel FE to Z. In this series, we are going to learn more about finite element analysis from the beginners to experts level. So I am going to share my experience. I hope that this will be more helpful to the engineers who are all begin entering into industry. First thing is we should know why we are using FEA technique. While coming to this point, we have several methods to solve engineering problems. First one is analytical technique. This is well known to everyone, and here we are using a mathematical approach. Actually, we have to formulate equations. Let's take this example. So, this is a cantilever problem. So, if we are applying load at one end, what will be the deflection at fixed end? That we can find out by using the formula like this, and we have to do the calculations manually, and this approach will give us a 100% accurate result, and it has some limitations. If the problem is very complicated or the geometry is very intricate in shape, so it is very difficult to formulate the equations. Then we have to go for numerical technique, which is nothing but finite element analysis. So this is also a mathematical approach, but we no need to formulate equations manually. We can use FEA softwares, and just we have to import CAD data, then we can solve the model. And this is approximate method, not accurate method like analytical technique. So to understand this, I will give one example. So let's take 10 plus 10 equal to 20. So let's take this as an example. So for better understanding, I am giving this problem as one engineering problem. So if we are using analytical technique, we will get this result exactly. So it will give 100% accurate result. So if we can't able to solve this same problem by using analytical technique, we have to go for numerical technique. Then the numerical technique will give us the result like 19.8, 19 like this. So this is very much closer to the actual value. So this is the difference between analytical and numerical technique. And if the problem is if it is very complicated means, so we can solve the same thing by using numerical technique. So next one is experimental technique. This is actual practical approach. So it requires prototype. We have to make a prototype to solve the model, and it is a time consuming and expensive method. Let's take this example. So this is automobile crash test validation. So here we have to make the prototype, and we have to use sensors to collect physical data. So it will take much time. So now we can compare numerical technique and experimental technique. For example, let's this project, if it take 11 months to complete, so if you are using numerical technique, just it requires 1 month. I am telling just an example. So we are it consumes very less times to get the result. While considering the accuracy, the analytical technique will give 100% accurate, then experimental, then numerical technique. So next one is while considering the time. So numerical technique will consume less time than analytical, and analytical will consume less time than experimental. So while trying to do or trying to start any projects, we have to consider these two things. We have to keep in mind. So accordingly, we have to choose the methods to solve that given problem. Next one is type of finite element analysis for practical solutions. So there are more FEA analysis. So depends upon the actual case. We have to choose the appropriate FEA procedure. First one is structural analysis. While coming to structural analysis, it is more about structures. The structure may be of metal structure, plastic structure, hyperelastic structure, anything. We are going to consider two things. One is safety, another one is durability. Safety is nothing but the damage prediction and stress concentration, and while coming to durability, it is more about fatigue. So how much life the structure will withstand for the given load. So In this, by considering these two things, it is fall under two types. One is static analysis and dynamic analysis. In static analysis, we are dealing with structure at static condition, so it will not move. And in dynamic analysis, it will fall into two different types: implicit dynamics and explicit dynamics. Well, coming to implicit dynamics, we have vibration analysis like NVH, noise, vibration and harshness. And in vibration analysis there are more load cases, there are more options, you will see it later detailedly. And while coming to explicit dynamic analysis, so here we are dealing with structural interaction between two different structures, and it is cross test, drop test, and metal cutting, metal forming. So this case, load case will fall under explicit dynamic analysis. So next one is thermal analysis. In thermal analysis, we are going to deal with heat, only heat transfer. So this is nothing but heat transfer analysis, and heat transfer is nothing but conduction, convection, radiation. So this all these three phenomena will fall into two different categories: steady state as well as transient state. In steady state, that heat transfer rate will not vary with respect to time, but in transient state the heat flow rate will vary with respect to time. So we will see more detail about this thermal analysis later. Next one is fluid flow phenomenon, that is nothing but computational fluid dynamics, and here we are going to deal with fluid flow. So that it will we are going to calculate the pressure at velocity at temperature, and fluid will be in contact with the structure, fluid will be in interaction with structures. So all these cases fall under computational fluid dynamics. Next one is multi-body dynamics, and this is same as structural analysis, but here we are dealing with dynamic loads. The body will not be at the given structure will not be at rest condition, it will be in dynamic condition, so that we have to deal with dynamic loads. For example, this is automobile gearbox and IC engine simulation, all will fall under multi-body dynamic simulation. Next one is multiphysics simulation. Electrical phenomenon, thermoelectric phenomenon, electromechanical phenomenon, this coupled type of analysis will fall under multiphysics simulation. So to solve any given problem, first we have to identify the problem, which of this load case will be suitable for that particular analysis. Then we have to go for the analysis. So then only you will get a reliable result with respect to actual result. So almost all the engineering practical problems will fall under any of this category. So this is very important one. So we have to choose the appropriate method, then appropriate solver also. So that details we will see in next slide. So I have listed out some most commonly used commercial FA tools. So it depends upon the applications. Application wise I have listed out. So first one is static structural. So here so this is software packages, and this is the corporation. Corporation owned that particular software. That information also I have listed out. So first one is Abacus. ANSYS. Abacus it is from Dassault system, and ANSYS it is from ANSYS. OptiStrat it is a linear solver, and it is from Altair Engineering. So that software package is called HyperWorks. So in HyperWorks, OptiStrat is the solver. So it has a number of interfaces. We will see detail later. So next one is LS Dyna. It is from Livermore Software Technologies. NX Nostrum from Siemens. MSc Nostrum from MSc Software Corporation. These software packages are very much suitable and will give a reliable result for static structural analysis. Next one is thermal analysis. The same software what I have listed for static structural analysis can be used for thermal problem also. So it has its own interface for thermal problems. And next one is NVH, noise, vibration and harshness, as well as acoustic analysis. Here that NX Nostrum is very efficient tool, which is from Siemens. And next one is ANSYS. Next one is Abacus. So these are the commonly used tools for NVH, acoustics as well as vibration analysis. Next one is fluid flow analysis, which is nothing but CFD, computational fluid dynamics. Fluent is the efficient tool, which is from ANSYS actually. So ANSYS has its interface, which is called Fluent. Next one is Abacus. Abacus has its own interface for CFD solutions also. Next one is LS-DYNA. So this is also very efficient tool next to Fluent. Next one is CFX. So ANSYS has its interface for CFX as well as Fluent. So ANSYS Workbench has this CFX as well as Fluent interface for fluid flow problem or coupled flow analysis. Next one is durability or fatigue analysis. So here ANSYS Abacus we can do durability analysis, but for damage prediction, failure prediction, damage degree, everything we have to calculate manually. But ANSYS this Abacus ANSYS has its own interface for common fatigue analysis, but Abacus has some extensions for durability analysis, especially for metals as well as rubber. For metal it is called FE-safe, and for rubber it is called Endurica. So that is the extension, we have to buy it separately. Next one is FE fatigue. This is a commonly used tool for durability analysis and efficient tool. So next one is NX Nastran SimCenter 30. Both are same. So SimCenter is nothing but the updated Siemens PLM portfolio. So Siemens has integrated all their PM tools into single portfolio called SimCenter, like SimCenter 3D, SimCenter NX, like that. Only they have segregated. So NX National also suitable for durability analysis. Next one is ENCODE. This is also efficient tool like FE fatigue. Next one is kinematics as well as multi-body dynamic simulation. So this ADAMS is the efficient tool for kinematics as well as multi-body dynamic simulation, which is from MSC Software Corporation. ADAMS stands for Automated Dynamic Analysis of a Mechanical System. Next one is NX Motion as well as SimCenter 3D. So NX Motion is nothing but the interface in NX CAD. This is also very much suitable for kinematic as well as multi-body dynamic simulation. Next one is Recrudyne, which will come in the ANSYS interface. This tool also we can do kinematics as well as multi-body dynamic simulation. Next one is Amazim. So this is generally about the multi-domain system development tool. So which is from Siemens, and here also we can interlink this Amazim environment into CAD environment for multi-body dynamics as well as kinematic simulation. This is also very much useful for this kind of simulation. So next one is CATA or virtual lab for kinematic simulation. So this is all about kinematics as well as multi-body dynamics. This one is the explicit dynamics. It's nothing but a crash, drop, metal cutting, metal forming. So most commonly used tool is hyper crash in automotive industry, or radius and palm crash. These are the most efficient tools for crash. Next one is Abacus. This is also a very efficient tool from Dassault system, and ANSYS and LS-DYNA also. So otherwise hyper crash, palm crash, Abacus, and LS-DYNA, ANSYS. So these are the order. If we are going to choose any software tool among these for especially explicit dynamics, so this is the order. Next one is multi-body simulation. I have listed out some known tools like COMSOL Multiphysics as well as Star CCM Plus from Siemens. Next one is optimization. So optimization it will fall under three categories: topology optimization, shape optimization, and size optimization. So we will see it later detailing about this optimization technique. And generally we have some tools for optimization, OptiStat, which I have listed out for static structure analysis in front previous slide. So that we can use for optimization also from Altair. And the next one is HEATS. It is from Siemens, and this is suitable for structural optimization as well as CFD flow optimization. So HEATS, it is from Siemens. Next one is Next Nastran, also known as SimCenter 3D. This is suitable for NVH optimization also. So this is all about optimization tools. Next one is pre-processing. It is not about analysis, it is about meshing. So generally FEA process contains two stages. One is pre-processing, next one is post-processing. Post-processing is nothing but getting the result, dealing with FEA result, plotting curves, plotting LD, like that only. So it is dealing with solved results. So pre-processing is nothing but preparing CAD geometry or converting the CAD geometry into FE model, finite element model, which is nothing but splitting the CAD model into a number of known elements and nodes. This is nothing but pre-processing. For that, I have listed some most commonly used tools: HyperMesh as well as ANSA. HyperMesh, it is the one interface in HyperWorks tool, and like what we have discussed about Radius as well as Abstract, and the same interface only has HyperMesh tool for meshing. So it is from Altair Engineering. Next one is ANSA. It is from Beta CA system. So these are the most commonly used measure in automotive industry. And in commercially we have more tools like DAP meshwork, some more tools. These are the most commonly used tools. So these are all about commercially available FEA tools. So that's all about day 1 content. Here I am going to show some topics what I am going to discuss in day 2 session. I request the viewers to leave their comments regarding this topic and how much it is useful to you, and what are the topics we have to discuss in this session, that you can leave as a comment. And thank you all.